All right, Mr. Ahmed here for 7.4. Goal for today is to work with parallelograms that are special. And these special parallelograms include rhombuses, rectangles, and squares. Before we do that, just want to go over a brief recap of everything we know about a parallelogram. And just kind of keep in mind, if the figure is a parallelogram, that means that the opposite sides are parallel. And based off of that, we know that the opposite sides are congruent. So these two sides would have the same length. And we also know that the opposite angles are congruent. So if this angle is x, this one across from it also has to be an x. And these would both be the same measure of a y and a y. We also know that the consecutive angles inside share a side. Those two have to add up to 180. So x plus y is equal to 180 degrees. They are supplementary. The final piece is if it's a parallelogram, then the diagonals bisect each other. So these two diagonals will cut each other in half. This piece is the same length as this one, and these two are the same length. So those were all the characteristics of a parallelogram. Now our special parallelograms will come with some other features as well. So the first thing we're going to talk about is what a rhombus is. A rhombus is a parallelogram that has four congruent sides. So it's not necessarily a square. These angles are not all right, but all the sides are the same length, okay? A rectangle, you've probably seen this one before. A rectangle is a parallelogram that has four right angles. So these opposite sides are also going to be congruent, just like we've always seen with rectangles. And finally, the square. That's the most special one. A square is a parallelogram with four congruent sides and four right angles. So all four sides are the same length and all four angles are 90 degrees. And kind of looking at this Venn diagram here, a couple things we talk about with this square. The square is the most special parallelogram because it is a rectangle, because it has four right angles. It is a rhombus because it has four congruent sides, and it's also a parallelogram. Its opposite sides are congruent, the opposite angles are congruent, etc. So when we kind of talk about these always, sometimes, or never pieces, a rectangle is sometimes a square, but a square is always a rectangle. Okay, same thing with a rhombus. A square is always a rhombus because a square always has four congruent sides, but a rhombus is only sometimes a square because it could have four congruent sides, but not necessarily the four right angles. So, looking at the special features of these shapes. A rhombus, if the figure is a rhombus, so if we have a parallelogram that's a rhombus, the diagonals are going to be perpendicular. So we have four right angles right in the middle for the rhombus. So that means that DB is perpendicular to AC. Those two sides form a right angle. Okay, so that's for a rhombus. The other piece with a rhombus is that the diagonals bisect the opposite angles. So these diagonals coming through cut these angles in half. So angle B, the whole thing, is divided into two equal parts. Same thing with angle C, divided into two equal parts. And this piece in the middle is still a 90-degree angle. And finally, for the rectangle, the special feature of it is that the diagonals are congruent. So A to C is the same length as D to B. The entire thing. Those are the same length. Now the other piece we have to keep in mind is since it's a parallelogram, they are going to bisect each other. So that means all of these little pieces, they're also going to have to be the same length because if this were 8 units, this is 8 units, and they bisect each other. So we'd have a 4, a 4, a 4, and a 4. Okay, so that's all of our special features for rhombuses, rectangles, and keep in mind the square, because the square will carry all of those features as well because the square is a rhombus and it is a rectangle. So moving on to some example problems. Got a lot of information to solve on these. We had a couple pieces that we aren't able to find, so I crossed that off. We can't find X, Y as of yet. We're going to have to use some things from a later chapter. So the first step, let's see what we know. We know that the figure is a rhombus. So a couple things. If it's a rhombus, I know that this is a right angle in the middle. These are all 90 degrees. I also know that these angles are all going to be bisected because the diagonals bisect the angles. So my first step is supposed to find WZV. So let's find angle WZV. WZV is right here. These two parts are the same length, so it is 34 degrees. I said length, they're the same measure. Our next part is to find WVZ. So W to V to Z, we already said that those are all right angles. So this is a right angle, 90 degrees. Next part says to find X, Y, Z. So X to Y to Z. Now this part's going to be a little more challenging. For me to find X, Y, Z, I need to figure out what this whole angle has to be. So since it's a parallelogram, I know that these two angles are supplementary. And this whole thing here is 34 plus 34, which is 68. So that's for the whole angle. So for me to find this whole angle, which is what I am trying to find, I need to figure out what this is. These two have to add up to 180. So I would take 180 minus 68. So let's see, what's 180 minus 68? We get 112 degrees for the whole thing. So I'm putting that on the outside because the whole thing's 112. Now a couple other ways you could have done it. We know that this is a triangle and this is a right angle. I could have also taken 180 minus 90 minus 34, which is 56, and I would have known that this little piece is 56, and both of these have to be the same size, so it would also be 56, which would still get us to 112. So angle XYZ is 112 degrees. Next piece is to find W to Y. So W to Y, diagonal. The diagonals of a parallelogram, a rhombus is a parallelogram, they bisect each other, so these are the same length. So this whole thing inside of here is 7 from here to here. The entire length is 14. And next step is to find angle YXZ. So let's locate YXZ, trace it out. Y to X to Z. Well, we know this whole thing has to be 68 because the opposite angles are congruent. They're cut in half. So this is a 34 and also a 34. And in a similar manner, this would be 56 and 56. So we have a 34 degree angle here. And the last step says to find YXW. So angle YXW, opposite angles are congruent, so it also has to be 68 degrees for the whole thing. And that is our first problem. So a lot of information there. On to our next one. Next step says the diagonals of a rectangle. So key word, it's a rectangle. That means I know that these are all right angles. Just going to mark 2 of them. And I am also told that angle ABD is 53 degrees. So this little one inside is 53. Together those have to add up to 90. I'm going to find that out right now just because I noticed it. So 90 minus 53 is 37. So this angle has to be 37 degrees based off the fact that that's 90. I'm also told that AE is equal to 9. So the other piece, the diagonals of a rectangle are congruent. So all 4 of these are the same length. So we'd have a 9 here, a 9 here, and also a 9 here. All 4 little pieces would have to be the same size. Let's see what we're supposed to find now. So angle BDC is first. B to D to C. All right, that's a little bit tricky. We got to keep in mind that this is a parallelogram, so these alternate interior angles are congruent. I could trace my Z, and 53 and 53 would make alternate interior, so this is 53 degrees. Next one's to find ADC. Oh, that's easy. That's a rectangle, so it has to be 90. A to C, we already marked the diagonals bisect each other, so 9 and 9. The whole thing has to be 18. And lastly, B to E is 9. All the little pieces were the same length. We're going to skip finding AB. We'd had to use some trig stuff, which we'll use later on in the year. Alrighty. On to our last difficult one here. And I actually had to remake this video because I screwed this problem up in the first one. Got a little flustered because I was crossing things off. So here we go. says the diagonals of a square. So we have a square. So that means it's a rhombus and it's a rectangle. So all 4 of these pieces have to be the same length, and it's going to be at a right angle. Has the properties of a rectangle and a rhombus. I'm also told that JG is 11. So from J to G, this piece is 11. So all of these have to be 11. All right. Next step says find angle FGH. So let's locate FGH. It is a square, so this has to be a right angle. That's 90 degrees. Next is to find HFG. HFG, again, 90, but keep in mind, these bisect, the diagonals bisect the angle, so half of 90 is 45 degrees. So these 2 little parts have to be 45. So HFG is 45 degrees. Next step, EJ, we already marked, that's 11. F to H, add the whole thing up, 22. And J to H is 11, and we skipped HG. Okay, we aren't going to find that piece. So, moving on to our last step, always, sometimes, nevers. Square. How often is a square a rhombus? Keep in mind the square is the most special one. A square is always a rhombus, because a square always has 4 congruent sides. A rectangle always has congruent diagonals. And a rhombus only would sometimes have 4 congruent angles. So it would have to be a square. All right, that's it for today. Have a good one.